Welcome to section 1.2, describing distributions with numbers. In this section, we're going to talk about measures of center, two of them which are the mean and median, the mean versus the median, measures of spread, quartiles, standard deviation. We'll talk about what the 5-number summary is, and box plots, and then choosing among summary statistics, and then changing the unit of measures. So this is part 1 of section 1.2. In section 1.1, we looked at the shape of our distribution. Now we're going to look at numerically where the measure of center and spread are. And both of these are very important in doing a data analysis. Now, which measures of center and spread depends upon the distributions of shape. So we're going to do a quick review. Now this review is very important. We're going to review population versus sample, analyzing populations versus analyzing samples. Now for populations, that means we know all of the data. We get descriptive measures of population, and we call them parameters. Parameters are often written with the Greek letters, such as mu, which is the mean. That's what we represent, the population mean. Mu is the lower Greek M, and it looks like a funky U. And we'll learn all the different Greek letters to go with the different parameters. Now, parameters define a population. Now, when we take a sample, and remember, a sample is we hope is a very good representative sample of the population or subset of the population. We won't know the entire population, so we take this subset of it. And when we get descriptive measures from the sample, we call them statistics. Statistics estimate parameters. So from our samples, we can only estimate what the parameters are. And our estimate, our statistic, is only as good as our sample. And we're going to find that the larger the sample, the better the estimate, generally speaking. Now, statistics are often written with Roman letters, and the very special one that you see here, X with a bar over it, is the sample mean. So the sample mean estimates mu, the population mean. So we're going to start off with the center of the data, the numeric value that represents the average or typical value of a quantitative variable. Now, examples of measures of central tendency are the mean and median, and those are the two that we're going to focus on. Now, variations or measures of dispersion, they're numerical values that represent the degree to which the values are spread out. We're going to concentrate on the range, the interquartile range, which we'll need our quartiles for, variance, and standard deviation. So let's start off with our central tendency, the mean. The mean, or the arithmetic mean, of a variable is often what people mean when they say, hey, let's take an average. You add up all your data values and divide by how many data values you have. So let's look at an example. We want to compute the arithmetic mean of these three numbers, 6, 1, and 5. So we're just going to add up all the three numbers and divide by 3. We get 4. But you see the 4.0. We add one more decimal place than our data has when we're calculating the mean of a sample or any calculation of a sample. So one interpretation would be that the arithmetic mean can be thought of as the center of gravity, where a yardstick would be balanced if the yardstick were our numbers. So there are as many values to the right of that number, that mean, as there are to the left of that mean, arithmetically speaking. Now here are some symbols. They can freak some students out, but it's really not that bad at all. It's just a shorthand way to write a formula. So you could either say sum up all the data values, divide by how many data values you have, and that's your sample mean or population mean. The symbol that says just what I said there is that strange looking E, but it's really the capital S, sigma, in the Greek alphabet. and that means to sum. And then you see this I equal on the bottom and an N on top. That just means to sum from my first data value to my very last data value. Because if you have N data values in your sample, you'll sum up your first to your nth data value and divide by how many data values you have. That's all that means. And when you see X bar, you know you're talking about a sample mean. When you see mu, you know you're talking about a population mean. Now, how we calculate the mean is exactly the same for both the population and sample, but what they mean is vastly different. One is a parameter that defines the population, that's mu. The other is an estimate of that parameter. It's not the true parameter itself, it estimates the parameter. Again, though, I want to emphasize how you calculate it. It's exactly the same. Now in this slide, it's working with the symbol and understanding what the symbol means. And this would be good for you to look at. What we see here is we can index our data values. So we index them x1, 2, 3. So when I see x with the little 1, sub 1, that means that's my first data value. X sub 2 is my second. So we could all talk about, oh, what's the third data value, and we'd all know what it would be. And that notation, like I said, the summation from I equal n of xi is just summing up all the data values from 1 to n. And we want to show that, are these two symbols the same? The summation from 1 to n of x sub I squared. So that means square all my data values and sum them up. And the next symbol that you see, where we sum up our data values and then square it, are those the same? And obviously, just the way that I said it, no, they're not, they're different. So we actually show, we get a data set 1, 2, 3, and 4, and we say that 1 is our first data value, 2 is our second data value, 3 is our third data value, and 4 is our fourth data value. And we do the summation from 1 to 4 of our x sub I squares, and we get 30 as our answer. And you can see the computation. When we want to square the sum of our data values, it's very different. We sum 1, 2, 3, and 4. We get 10, and then we square it, and we get 100. So very different calculations, and that's really just basically order of operation. This is very mathematical. But it's showing you how to use the symbols. Now back to doing some statistics. Here's our data set, 1, 4, 5, and 10. So my first data value is 1, my second data value is 4, my third data value is 5, and my fourth data value is 10. And I want to find the mean. So I'm going to add up all my data values from 1 to 4 and then divide by 4. So I add 1 plus 4 plus 5 plus 10, divide that by 4, and I get the mean of that data set to be 5. And since this is a sample, I get one more decimal place of accuracy than my data has, so my answer would be 5.0. Not going to be a complete stickler on the rounding, like in other words on the test, which are multiple choice. I won't put 5 and then 5.0. You'll just see 5.0. I'm not going to try to trip you up on that. However, I do want to emphasize that we should do the correct rounding. If we wanted to use Minitab to find the mean, here's a way to do it using a command. I'm going to show you a way to do it just using Minitab's drop down, because as I said, I'm trying to teach you to use Minitab outside of this class, and to do that you'll probably not remember the commands, but you certainly will remember how to use the drop downs, because it's very easy. So what I'm going to do is I'm going to work in Minitab. Remember, the first thing we do is hit in the sessions window and enable our commands, and we could do that command, the mean, and I'm going to put in the data values. And I'm going to show you how we can use a drop down to do the very same thing. We could put that command in right there and say the mean of the data values in my first column and get just what we see there. So our mean would be 5.0. Or I could say, hey, I want to do basic statistics, describe them, and I'll get this box. And I'll say those are the variables that I want, and I go into statistics, and I can pick and choose what I'd like. So if I just want the mean, get rid of all these check marks, hit OK, and out will pop the very same thing. And I can custom make it to whatever I want. I could say, hey, I want more than the mean, I want the standard deviation, I want how many are in my sample, and I want the median and the interquartile range. Hit OK, and all of those will come out for us. So you can custom make this. So that's where we're going to end in part 1, and we'll continue looking at the mean and median in Part 2. Thank you.